This is the second of our videos on condensation management. The 2022 NCC condensation management provisions build on the initial 2019 provisions and are developed to further decrease health risks and building damage associated with high moisture levels in new homes. They are included in both Volume 1 and Volume 2 and are therefore mandatory in all residential home construction. This video is designed as a simple and practical summary of the third of the three sections of the regulation, ventilation of the roof space, including suggestions for builders and contractors, with developing effective, simple and cost-efficient solutions. For simplicity's sake, we will refer to the section numbers of Volume 2, the Condensation Management section. 10.8 has three subsections. Subsection 10.8.1 deals with insulation and vapor permeable membranes. 10.8.2 covers exhaust systems and was covered in our previous video. 10.8.3 covers ventilation of the roof space and is reviewed here. The information in this video is contained in our Condensation Management Handbook. See the link in the comments below. Here is an excerpt of the regulations. We will explain this in simple and practical terms. Unlike exhaust systems in 10.8.2, this section only applies in climate zones 6, 7 and 8, in mild, cool and alpine regions of Australia. There are some additional exceptions that also do not require 10.8.3 compliance. These include if there is a solid concrete roof, the roof is constructed from structural insulated panels, the roof is in a bow bushfire FZ zone, or if the roof is an unsarked tiled roof. Additional construction requirements are that the roof must be located above the primary insulation layers, and the sarking above the primary insulation layer has a vapor permeance of not less than 114 micrograms per Newton second, and that the ceiling insulation under the roof meets the requirements of 13.2.33 and 13.2.34. This video is focused on the ventilation requirements rather than the insulation requirements. Venting at the eave. Venting at the eave is required for all homes covered under the regulations, though the amount of ventilation required will vary based on several factors. This requirement has become increasingly complex as some modern homes do not have an eave. Options include non-ducted eave vents, fascia vents, and also structural products designed to create airflow between the roof and fascia, such as plastic over fascia vents. Alpine ventilation has two white metal 400 by 200 mm eave vent options. A steel one with an open area of 19,000 square millimeters, and an aluminium one with an open area of 21,000 square millimeters. These are simply screwed into the eave sheets. We also have 600 by 120 millimeter aluminium fascia vents in 9 popular ColourBond colors. A rectangular hole is cut into the fascia and the vent is riveted in. They have an open area of 21,590 square millimeters per vent. Aluminium eave vents are our recommended option for buildings that have eaves. In situations where buildings don't have eaves, fascia vents are a great option. All of our fascia and eave vents are available in twin packs. Venting at the high level. Roofs with a pitch of 10 degrees or more require high level venting. The aim of the 10.8.3 regulations is to draw cooler air up through eave venting and expel warmer air out at a higher level to create circulation. Options for high-level venting include traditional roof vents, low-profile roof vents, rotary vents, and openings built into the ridge capping. All have different implications, including purchase cost, durability, appearance, and installation complexity. We recommend the low-profile roof vent range constructed from aluminium and stainless steel. It is easy to install on metal or tiled roofs, is available in 9 ColourBond colors, so will blend with most roofs, and has mesh which is Balfour compliant, so is ideal for bushfire regions. Unlike rotary vents, it is unobtrusive and has no moving parts. Calculating requirements. This table is used to determine what is required to make a specific home compliant, whether the roof pitch is under 10 degrees, 10 to 15 degrees, or over 15 degrees. The first step is to confirm which product or products you wish to use, and the open area in square millimeters of the product or products. The second stage is to determine the length of the house. As per the table notes, the length of the house is determined as the longest horizontal dimension of the roof. The third stage is to determine the pitch of the roof. There are different requirements depending on whether the pitch is under 10 degrees, between 10 and 15 degrees, or over 15 degrees. Finally, confirm whether the roof has a cathedral ceiling or not. For our example, we will choose to use low profile roof vents and the aluminium eave vent. We will assume the length of the house is 22 meters. The pitch of the roof is 22 degrees. Therefore, looking at the table, this house needs 7,000 square millimeters per meter at the eaves and 5,000 square millimeters per meter at the high level. So to calculate the number of aluminium eave vents required at the eave, we calculate 7,000 multiplied by 22 divided by 21,000. This is 7.33, which we round up to 8 or 4 twin packs. And to calculate the number of low profile roof vents required, we calculate 5,000 multiplied by 22. The length in meters divided by 29,040. The answer is 3.79, which we round up to 4. Vents should be evenly spaced and should look similar to this. For more information, go to our website alpineventilation.com.au or check out the product videos on our YouTube channel. If you like this video and want more ventilation tips, check out our website and read the Condensation Management Handbook, like and subscribe.